All right, this lesson, we're going to learn about solving linear inequalities. These are your objectives. And our vocabulary: a linear inequality in one variable is an equation that can be written in the form ax plus b is less than c, where a, b, and c are real numbers. A cannot equal to 0. And also notice that this symbol less than can also be replaced by greater than, less than or equal to, or greater than or equal to. So it's very similar. We've already solved equations with equality. Now we're just going to simply solve them with inequality. Graphing solutions to linear inequalities. First of all, we're going to use a number line for linear inequality. We used a closed circle if it is wanting to include the point. So like less than or equal to or greater than or equal to, we use a closed circle, and an open circle if it's just less than or greater than. So in set builder notation, all x such that x is less than or equal to 7, because it's or equal to, we have a closed circle, and we start at 7 and it's less than 7. This represents the set of all x such that x is greater than -4. Notice it's just greater than, it's not or equal to, so it's an open circle, and it goes to the right of a -4. So this is how we represent on a number line for a linear inequality. Now, using interval notation, it's similar to set notation. However, when we're going to include the point, or if it's an or equal to, we use a bracket. Notice it's negative infinity. We read left to right, negative infinity, all the way up to a 7, and 7 is included. Now on the 4, -4 was not included, so it's -4 to positive infinity. So this is called interval notation. And on the lesson today, that's what we're going to be writing our solution as, in interval notation. One thing to notice, we always use a parentheses with the infinity symbol because we can never include infinity because it goes on forever. So whenever you're listing infinity, notice it's always a parentheses. You will find this information on the chart on page 78 in your text. The addition property of inequality is very similar to the properties of addition property of equality, in that if you add the same thing to both sides, it keeps the inequality true. And also for the multiplication property of inequality, if you multiply both sides by the same quantity, it keeps it true. If a, b, and c are real numbers and c is negative, then it's still, notice that when you are multiplying by a negative number, how you reverse the symbols. If you multiply or divide by a negative number, notice you're going to have to reverse your inequality symbol. This you'll find on the chart in your text on page 80 is how to solve linear inequalities in one variable. It's important to have this in your notes. We're going to solve inequalities as you would begin solving an equality. Same, you would start by distributing the 5 across the parentheses. We're going to subtract 3x from both sides because I like keeping my coefficient with my variable positive. Now let's add 5 to both sides. And this is multiplying the variable by 2, so we're going to divide both sides by 2. So x is less than or equal to 7. Notice that it always points to the smallest term. In interval notation, we are including 7 because it's or equal to, and it's less than 7, everything less than 7. So our solution would be negative infinity to 7. Okay, this one's a little bit more complex. We've got 2 sets of parentheses, so let's start on using the distributive property to eliminate our parentheses. Now we've got some like terms, so let's combine our like terms by simplifying both sides. Very good. Let's subtract 4x from both sides and simplify. Now let's add 14 to both sides and simplify. And we have x multiplied by 4, so we're going to divide both sides by 4. Negative 9 halves. Very good. You're ready to begin practice on your own.